Currently, you can create so many amazing things on the web. You can even create full applications like Photoshop, Figma. They are all amazing achievements that have happened in the last couple of years. With WebAssembly, you could even write high-performing applications in low-level languages like C, C++, and Rust that can comfortably run on the web. And if I think about it as a web developer, all these insane things you can do on the web makes more sense to be called Web3 than what we currently call Web3. I don't know, think about it. We are going to start small with the SVG. Like the name, it stands for Scalable Vector Graphics. It's a type of graphics that deals on vectors. Vectors are basically the use of mathematical formulas to create colors and shapes that are infinitely scalable. There's so much you can do with the SVG. It's like a DOM in the DOM. So you could create text, you could create everything you can create in Figma inside an SVG. And you could even save this as an external file and link it through the image tag. With SVG filters, you can create awesome animations like these. They're a bit subtle, but you probably can see something going on. There is only one thing cooler than the SVG, and that is the canvas. The canvas is an element used to draw graphics. It basically handles so much more mathematical computations behind the scene, and at every frame, it sends a picture output to the CPU to render on the canvas elements. It's a bit crazy if you think about it, like so many cool things. You could have a game that sends 60 different images to your website in a second, and in those 60 images it does a lot of calculations to calculate the lighting, the gunshots, the angles, the models. It's just so crazy. But again, we are going to start even smaller. Unlike the SVG where you could write markup and styles inside the SVG tag, we don't have that with the canvas, so everything that happens on the canvas is basically on a script. There are so many libraries that makes this so much easier for developers, and the library of choice today will be P5.js. P5.js is a JavaScript library we could use to create amazing 2D graphics on the web. The two most important functions in a P5.js code is the setup and the draw. The setup basically tells the CPU to prepare the canvas for whatever we are about to do with it. And the draw is the function that runs at every frame, which could be 60 times in a second, and it gives the CPU an image every time to display on the canvas. We are going to be creating these while I try to explain P5.js. So the first thing we are going to do in the setup is create the canvas. We need to pass in the width and height of the canvas. In our draw function, we are going to give the whole canvas a background of Peru, and this runs at every second, at every frame. So we have a nice canvas from Peru. Next, we are going to define all our rules. Since this doesn't exactly have anything to do with P5.js, we could have them outside the functions. So we are going to create an object with title, color, and width fields, and an array of these objects. In the draw function, for each of these rules, I want to create a pair. And we are also going to create the function that creates the pails. And for this, we just want to create a text. The first parameter to creating a text is the text itself and then the coordinates. We are going to align the text to the center. The order in which you write this actually matters, so anything that comes before the text is applied to the text when it's finally created. And since the text won't be the only thing here, we actually need to make every pill a group. To create a group, we use the push function. So next, we need to create the background of the pills, fill it with the specific colors, and also make them the width of the text. Now, you might be wondering how I'm getting all this. The most important thing is having the vision. As long as I know what I want to create, I could always Google what I want to create, and it leads me to the documentation, which is so well documented. We could also add a radius to the rect. And I'm going to offset the rect and the text so they are all in the middle and sitting pretty. We still have a long way to go. We've not even talked about the physics. I might continue on the next video, but there's just so many other interesting things I want to talk about. So make sure you subscribe to my channel and I'll be seeing you.